Okay, so we're looking at this question. First step is always to plug in. When we plug in over here, we do not have a basic limit law. And so that tells us that we need to divide by the highest power in the denominator. So divide denominator. And when you look at this, just keep in mind, like, this is x minus the square root of x. You can rewrite as square root of x is x to the first power, and then the understood index of the square root is 2. So the square root of x is x to the 1/2 power. So when you look at the denominator here, you have x to the first minus x to the 1/2 power plus 1. So your highest power is going to be the x to the first. So remember, dividing the denominator, you're looking at the highest power, and that's what you're going to divide by. All right, so in this case, we're going to be dividing by x to the first. All right, so looking at this, we're going to have x go into infinity, 2 square root of x. We can divide that by x over x divided by the square root of x minus square root of x over square root of x plus 1 over the square root of x. All right, so the next step after we divide, of course, is to simplify. So here we have to use our understanding of fractions and subtracting the exponents. So keep in mind that in this numerator here, because of the fact that the square root of x is the same as x to the 1/2, you're really looking at 2x to the 1/2 over x. And if I subtract these exponents, I'm going to have 1/2 minus 1. That gives us a negative 1/2, which I would then put in the denominator. So this simplifies as 2 over x to the positive 1/2. All right, so that is just for this numerator, 2 square root of x over x. So this will look like 2 over x to the 1/2 power over. Now, in the denominator here, you have this x over the square root of x. So what happens with that, and let me just write it kind of off to the side here, you would rewrite that as x over x to the 1/2. When you subtract your exponents, you would have 1 minus 1/2, and that would give you a positive 1/2. So our x over the square root of x is going to become x to the positive 1/2. These square roots cancel out, so we have minus 1 here. And then the plus 1 over the square root of x, there's nothing to do there. All right, so now we need to try to use our basic limit laws. And we didn't really emphasize this too much in class. We said that if it's a power p, so if it's a number over x to a power p, that will go to 0. But there is an assumption there that p is not negative. So the fact that I have a 1/2 power is fine. And I want you to think about this as if you plug in, so if I just plug in a big number, I'm going to have 2 over a big number raised to the 1/2, or 2 square root of a big number. And if you take the square root of a big number, you still have a big number. So it's going to work for the x to the 1/2 just in the same way it would work if we had to the 3rd power. Okay? So this 2 over x, that's going to go to 0. This 1 over the square root of x, that is also going to go to 0. Now this x to the 1/2 here, that is not going to go to 0 at this time. All right? So let's just focus on that basic limit law. We now have 0 over the square root, or x to the 1/2, minus 1, and then the plus 0. Now, we said that if there's ever an x left over, then what we need to do is we need to plug in. So if the x is still there, and in this case it is still there, we are going to plug in, and we plug in our infinity. Okay, so when we plug in, we're going to have 0 over infinity to the 1/2 power minus 1. And so that gives us 0 over a big number. And we know that when we have a big number in the denominator, this is going to go to 0 as x goes to infinity. So our final answer here is that it's going to be equal to 0. And another way of thinking about this also is you have 0 over something, and that is not equal to 0. It's going to 0, but it's not equal to 0, and therefore it will be equal to 0.